Hello, my dear students. My name is Narayana. This is Ellen brand of chemistry. Today we are going to discuss about Faraday's laws of electrolysis. In the previous session, that is lecture number 6 in the electrochemistry. So we are discussing about the electrolysis. So now we have to discuss about the Faraday's laws of electrolysis. Faraday's laws of electrolysis. Faraday's laws of electrolysis. So in the previous session, we are discussed about the electrolysis. So what is electrolysis? Electrolysis nothing but we have to take the electrolytic cell. In the electrolytic cell, one is we have to take as anode, one is we have to take as cathode. So anode having positive charge in the electrolytic cell, then cathode is having negative charge in the electrolytic cell, then electrolytic solution will be present. When current is passed through in it, then anion, that compound will be dissociate as anion as well as cation. Anion ga cation ga dissociate out. So now anions are moved towards the anode. So this is anode. So why anions are moved towards the anode? Because it is a negative charge, then this is positive charge. So oppositely charged that are moving towards the oppositely charged, right? So this is also moved towards the cathode. So that's what we are calling it as a cathode. So cations దాని వైపు మూవ్ అవుతా ఉన్నాయి కాబట్టి దాన్ని cathode అంటున్నాం. Anions దీని వైపు మూవ్ అవుతా ఉన్నాయి కాబట్టి దీన్ని anode అంటున్నాం. So this is what we are calling cathode. So cathode having negative charge, then anode having positive charge. So now here at anode what happens? At anode anions oxidation takes place. So that is oxidation takes place, that is, so by the loss of electron, then this will be discharged. One of the compound will be discharged at anode. One of the chemical compound is discharged at anode. The same thing at cathode it takes place. At cathode, in case if you take, so what will be there? Cation will be there. Cation, by taking off one electron, it will be converted into compound, right? So chemical compounds are produced. A chemical compound is produced at anode and cathode. So this is called electrolysis process. So in the previous session that we are discussed electrolysis. Sir, in this session, how much amount of produced? Idi enta amount produce ayindi? Amount of substance that we are talking in it. Clear all of you? So that amount it is explained by the Faraday's law. Sir, in that first law of Faraday. Sir, first law of Faraday. First law of Faraday. So what is the Faraday's first law? So that is the amount of substance deposited or liberated at electrodes is directly proportional to electricity, the amount of electricity passed through in it is called as Faraday's first law. So what is the Faraday's first law? The amount of substance deposited or liberated at electrodes is directly proportional to current passed through in it. Electric current passed through in it. So simply amount of current passed through a net or amount of charge is passed through in it. So that we are called. So amount of substance is, that is the mass of substance is directly proportional to quantity of current. Quantity of current. So amount of electricity, nothing but quantity of current. Quantity of current. So M is directly proportional to Q. So generally we know that the I current, it is equals to Q divided by, that is time, within the time. So this is the formula for current I, right? So from this equation, then we can get it is Q equals to I into T, right? I into T. So in the place of Q, we can substitute I into T. Then proportionality constant, that is, so M equals to Z into, then I into T. Z into I into T. So Z is what? Equivalent substance. So equivalent substance. Equivalent substance. Equivalent substance. That is equals to then equivalent weight divided by 1 Faraday of charge. When 1 Faraday of charge is passing through the electrolyte, then 1 equivalent weight of the substance is formed. That is, we are calling it as a Z. So 1 Faraday of electricity pass cheste ఎంత amount of substance produce అవుతుందో, that is called Z. So here, so in the place of Z, that we can substitute E divided by F. So M equals to, then in the place of Z, E divided by F we are used. Then Q, that is I into T, right? Then we know that E nothing but, here E nothing but equivalent weight. Equivalent weight. So in the equivalent weight, that is E, it is equals to then molecular weight divided by N factor. Molecular weight divided by N factor. So in the place of E, that is M, it is equals to, in the place of E, we can write it is molecular weight divided by then N factor, so into 1 divided by F, into I into T. So this is the formula for calculate the mass of the substance by using Faraday's laws. So what is there? Mass equals to then molecular weight divided by N factor into 1 by F, then into I into T. So here, what is the MWT? That is molecular weight, N factor. It is depends upon the compound. So in this, the charge of the substance, you have to, number of electrons, how many transferred in the cation and anion, that is at cathode and anode, that we have to take as N factor. Then Faraday, 96,500 coulombs you have to take. I current, then time T in the seconds you have to take. That is Faraday's first law. So we will see, so all the terms, whatever it is there. So what is the Faraday's first law? The amount of substance that is deposited or liberated at electrodes is directly proportional to quantity of current passed through in it. Quantity of current passed through in it. So that is formula. M is directly proportional to Q, I told. Then Q nothing but what I told. So I into T. Then proportionality constant in case if you use Z into, so I into, then T, Z into I into T. Z nothing but what I told, equivalent weight divided by Faraday. Then equivalent weight equals to what? Molecular weight divided by, then N factor have to use. So in the place of Z, you can use that molecular weight divided by N factor into, then 1 divided by Faraday into, then I into T. So this is the formula for, Faraday's first law of electrolysis, right? So what is that? So it is a molecular weight, then so NF, nothing but N factor. So N factor, it is a charge of cation, or simply you can say the number of electrons transferred in it. Number of electrons, number of electrons transferred, number of electrons transferred. Then next F equals to, we know that 96,500 coulombs we are using in the calculations in the previous also, right? Then time T, time you have to take in the seconds lo తీసుకోవాల్సి ఉంటుంది time. So these are the values. Then I is what? I equals to current. I equals to current, that we have to take. This is the terms. Then based on these, sir, we have to do some of the calculations. Then it will be understand very clearly, sir, what we have to discuss. So then note it. So note a question. Find the amount of copper deposited. Find the amount of copper deposited. Find the amount of copper deposited when 5 amperes of current is used for 1 hour. Electrolyte copper sulfate, CuSO4, aqueous copper sulfate, CuSO4 solution. Then atomic weight of copper is given. Atomic weight of copper, it is equals to 63.5 is mentioned. Then 1 Faraday, that is equals to 96,500 coulombs, even that also mentioned. Then options are given: 4.2 grams, then 5.9 grams, then 6.6 grams, then 8.2 grams. So these are the options: A, then B, then C, then D. So look at the question once. If you observe, find the amount of copper deposited when 5 amperes of current is passed through for 1 hour through electrolytic solution of copper sulfate. Then what is the amount? They're asking question. So look at, my dear students, what formula you have to use. This formula you have to use. Sir, all the values will be there or not, we once check it. Molecular weight, that is atomic weight, is given here. So atomic weight of copper you have to clear. Then N factor. So N factor, how it will be understand? Copper sulfate solution that will be dissociated into Cu plus 2, then SO4 minus 2. Copper deposit avvalante Cu plus 2 electrons, then copper will be deposited like this. So for the deposition of copper, how many electrons are required? That is, we call it as N factor. N factor, have to take that. Clear all of you? So N number of electrons, that is 2. So now mass of the substance deposited, that we have to take. So molecular weight, or here atomic weight, atom only na. So atomic weight divided by N factor, so into 1 divided by Faraday into I into T. Clear? So atomic weight, what we have to take? 63.5. Then sir, N Faraday, sorry, N factor, that is 2 number of electrons have to take. So into Faraday, so 96,500 coulombs. So into I. Sir, I value how much is given? Sir, amperes, 5 amperes into. Then time, 1 hour is given. But I told that time you have to take in the seconds itself. So seconds lo తీసుకోవాలంటే 60 minutes అవుతుంది. మళ్ళీ 60 తో మల్టిప్లై చేస్తే 60 seconds అవుతుంది. Then so look at here, sir, 2 zeros, then 2 zeros will be cancelled here. Then 2 1s, then 2 3s. Then if you do that multiplication, you can get the answer, that is 557. So that is 5715 divided by 965. It is equals to 5.9 grams you can get. So this is the answer, 5.9 grams you can get. So understand, my dear students. So if you do the problem based on the formula, then you can get how much substance is deposited or liberated at electrode. So tell me one thing, the copper is deposited at the anode or cathode? It is a cathode. So because the plus 2 charge will go to the negative electrode. Negative electrode in the electrolysis is cathode. So that's what we have to observe it. Understand? Yes, note it. So next, one more question we have to do based on it. Yes, Faraday's electrolysis. So formula is mass of the substance equals to molecular weight divided by n factor into 1 by F into I into T. I nothing but current, T nothing but time in the seconds. Right? Yes. So now one more question, note it. That is 2 Faradays of electricity is passed through a solution of copper sulfate. What is that? 2 Faradays of electricity. 2 Faradays of electricity is passed through a solution of copper sulfate. A solution of copper sulfate, CuSO4, copper sulfate. The mass of the copper deposited at cathode is the mass of the copper deposited at cathode is. They're asking question like this. So what formula I told? Faraday's first law. So Faraday's first law. So here that is what I told. Then mass of the substance is equals to molecular weight divided by n factor into then 1 by F into then sir quantity of current Q. Q nothing but here what I told, quantity of charge or quantity of current. So quantity of current or quantity of charge, how many Faradays are given? 2 Faradays are given. So here copper only, again the copper atomic weight now we only are seen. So atomic weight you have to take this is. So atomic weight how much is given? 63.5 is given, my dear students. Yes. Then 63.5 n factor how much? 2. N factor is 2. Then 1 divided by 96,500 coulombs. Clear? Right. Then 96,500 coulombs. Just leave it. Then Faradays as usual. Note it. Then here I told that Q it is equals to 2 Faradays. There mentioned the 2 Faradays of electricity. Clear, my dear students? Then 2 Faradays. So Faraday cancel. Right. So 2 cancel. Then you can get it is 63.5 grams of substance is deposited or liberated at electrodes. Okay. Understand? Yes. Yes, note one more question here. So just note it. So one more question. So question number 3, we'll see. Question number 3. That is electrolysis of aqueous dilute NaCl. Solution was carried out. Solution was carried out by 10 milliamperes. Carried out by 10 milliamperes. 10 milliamperes of current. 10 milliamperes of current. The time required to liberate, liberate time required to liberate 0.01 mole 0.01 mole of H2 gas at one of the electrode is at one of the electrode is they are given like this. Even options also is mentioned. So A, that is 6.4 into 10 to the power of 4 seconds. Then B, that is 9.15 into 10 to the power of 4 seconds. Then C, 19.3 into 10 to the power of 4 seconds. Then D, that is 10 to the power of 4 seconds. Clear, my dear students? So here, one of the things you have to observe, then hydrogen gas will be liberated cathode or anode? Cathode or anode? So at cathode it will be liberated, oxygen will be liberated anode, hydrogen will be liberated cathode. So at cathode what reaction takes place? At cathode, then this is aqueous dilute NaCl solution, right? So when aqueous dilute NaCl solution, if we take, sir, water and as well as sodium, both will be competitive. So oxygen, then sodium reduction potential values and water reduction potential value, when compare, water reduction potential value is greater than that of the sodium. So water only reduction takes place. Then 2H2O plus 2 electrons is sliced to. Then H2 plus 4O 2OH minus. 2OH minus. This is the equation. Clear, my dear students? Then 2 moles of water in case if we take, then how many moles of 1 mole of hydrogen gas will be liberated. So here, then in case 0.01 mole of hydrogen gas, so actually we have to take it as time required for the electrode, right? So here Faraday's need not to take H2O, then how many electrons are involved in it? So that is 2 moles of electrons, nothing but 2 moles of electrons, nothing but 2 Faradays of electrons. Clear all of you? Right. Then for the 1 mole of gas, then 2 Faradays, then 0.01 mole of gas, then in case if you take, then 0.02 Faradays of electricity will be produced. Then here this is the quantity of current Q, quantity of current. Then quantity of current Q, it is equals to I into T, I told, right? I into T. Then quantity of current we got it is 0.0202 into what? Faraday. Then I value, that is 10 milliamperes, 10 into 10 to the power of minus 3, milli nothing but minus 3 amperes. Then time T. So we want time now. So time T, it is equals to, then so 2 into 10 to the power of minus 2, you can write 2 into 10 to the power of minus 2. Sir, 1 Faraday equals to 96,500 coulombs. So 1 Faraday value 96,500 coulombs. So then divided by, so this is, we can take it as 10 into 10 to the power of minus 2. So 10 into 10 to the power of minus 2. So 10 to the power of minus 2, 10 to the power of minus 2 cancel. Then 2 into 96,500 coulombs, that is 193, then zeros you can get. So now the value point when it is shifted to there, then you can get it is 19.3 into 10 to the power of 4 seconds. So that is the answer, 19.3 into 10 to the power of 4 seconds. So this is a question and answer like this you have to do. So in case such type of questions are given. Yes, note my dear students, we will do one more question based on it. Yes, look my dear students, one more question we will do based on it. One more question. Sir, how much amount of substance is deposited or liberated at electrodes? సో దీన్నే డిఫరెంట్గా ఎలా అడుగుతా ఉన్నాడు, సరే ఎలా అడుగుతున్నాడు అనేటివి ఆల్ టైప్ ఆఫ్ క్వశ్చన్స్ దీస్ ఆర్ రైట్. So one more question you'll see, that is for molarity of aqueous NaCl is prepared and 500 ml of this solution is electrolyzed. This leads to evolution of Cl2 gas at one electrode. Then atomic mass is mentioned, atomic weight is mentioned, that is 23. Total moles of Cl2 gas evolved is total moles of Cl2 gas evolved is, any question again? Sir, options are given, that is 0.1 mole, then 2 moles, then 3 moles, then 1 mole, like this is given. Sir, observe my dear students, the molarity is given. So for molarity of aqueous solution is given. That in that 500 ml of solution, when it is electrolyzed, chlorine gas is liberated. ఈ chlorine gas ఎన్ని moles liberate అయ్యింది అడిగిన క్వశ్చన్. ఎన్ని moles liberate అయ్యింది? How many moles of total moles of Cl2 gas is evolved or liberated? So both are same. Evolved nothing but so liberated, right? So first from this, the molarity, it is equals to number of moles divided by volume in the milliliters. Volume in milliliters you can take. So when we are taking the milliliters, so that is n into 1000 divided by then volume in milliliters you can take. This is the formula. So from that number of moles you can find out, right? So number of moles is equals to molarity into volume in milliliters divided by 1000 you can take. So here molarity is given 4, then into this is volume is given 500, then divided by then 1000, then you can get it is 500 once 2 times, 2 times. The number of moles you can get it is, so this is the number of moles of aqueous NaCl. Number of moles of aqueous NaCl. So NaCl 2 moles if you take, NaCl 2 moles. When it is electrolysis cheste, then 2 moles of sodium plus 2 moles of chlorine or chloride, sodium ions and chloride ions will be produced, right? So now at anode in case if you take anode reaction, if you take, then anode is a positive charge, right? Then negative part will be moved towards that. So that is 2Cl minus, then Cl2 plus 2 electrons. So look at 2 moles of sodium chloride when it is involved in the electrolysis. Then 2Cl minus ions you can get. Then 2Cl minus ions liberate 1 mole of chlorine gas, 1 mole of Cl2 gas. So that's what, my dear students, the 1 mole is answer. That is the 4th option is correct answer. Understand? Yes. The next question we'll do, then note it. Look, my dear students, one more question we will do. Yes. One more question based on the Faraday's first law. All these are questions are based on Faraday's first law only. Still we are not discussed about the Faraday's second law, right? So look at next question. A current of 2 amperes passed for 1 hour. A current of 2 amperes passed for 1 hour. 1 hour through a solution of through a solution of AlCl3. There are mentioned that is molten state. Has a current efficiency current efficiency 50%. Find the amount of aluminum deposited at cathode. Find the amount of aluminum deposited at cathode. Find the amount of aluminum deposited at cathode. Options are given. A, that is 1.33 grams. Then B, it's given 0.66 grams. Then C, it is given 0.33 grams. Then D is given, that is 1.66 grams. Clear, my dear students? Right. So here, the efficiency of current 50% అని అన్నాడు. సరే యాక్చువల్లీ ఎంత కరెంట్ పాస్ చేసాం? 2 amperes ఆఫ్ కరెంట్. ఇందులో 50% ఎంత? 1 ampere ఆఫ్ కరెంట్. Yes, efficiency of current. Yes, actually efficiency of current equals to I output divided by I input into 100. This is the calculate for current efficiency. The current efficiency is given the 50% is right. Then I output you have to find out. Then I input how much is given? 2 amperes. 2. Then it is 100. So here the 50 once 52 times, then 2 cancel, then I output you can get it is then 1 ampere. 1 ampere you can get. The current it is. Then what I told, aluminum how much deposited at electrode, at cathode. So aluminum at cathode ఏం జరుగుతుంది? cathode దగ్గర Al+3 ఎక్కడది? cathode దగ్గర ఏం జరుగుతుందిరా? రిడక్షన్ జరుగుతుంది, రైట్? 3 moles of electrons, then it will be converted into Al, aluminum. సారీ, పవర్ పోయింది, కరెంట్ ఒక్క నిమిషం. Yes, look my dear students. So Al+3 by taking of 3 electrons aluminum deposit అవుతుంది. So n factor, that is you can get it is a 3. Then mass of the amount of aluminum, it is equals to atomic weight divided by n factor into 1 by 96,500 coulombs into I into T. This is the formula, right? Yes. Then mass of the substance, that is aluminum atomic weight 27 divided by, then n factor is 3, then I into T, I value enta sir 1, then T time, so that is how many hours? Sir 1 hour I mentioned, 1 hour, so that is 60 minutes into 60 seconds, so 96,500, then 2 zeros cancel. So 3 1 times, then 3 2 times. Then mass of the substance, 27 into 12 divided by, so 965 if you do, then you can get it as 0.33 grams, you can get answer. Thank you. So here this is the answer. Okay, yes, note it. Yes, look, one more question we'll discuss. One more question we'll discuss. So that is a charge of 1 Faraday of a charge of 1 Faraday, a charge of 1 Faraday, amount of substance deposited, amount of substance deposited అంటే 1 Faraday of amount 1 Faraday of electric charge పాస్ చేస్తే సరే ఎంత amount of substance deposit అవుతుంది, that is the question. So they are given 1 mole of substance, options 1 mole of substance, 1 mole of substance, then option B, that is 1 gram of substance, 1 gram of substance, then option C, that is 1 gram equivalent of substance, 1 gram equivalent of substance, then option D, that is 1 atomic mass unit of substance, atomic mass unit of substance. Clear, my dear students? So now we have to find out the mass of substance, amount of substance, nothing but mass of the substance. Same Faraday's first law we have to use. So amount of the substance is equals to, so what is there, given weight divided by molecular weight, so that all the formula. But ఇక్కడ ఏ substance అనేది మనకు తెలియదు కదా. So how we have to use, that is Z, that is Z we have to use, then Z into a Q, Z into Q we have to use, then mass equals to Z nothing but what, so Z nothing but equivalent weight divided by Faraday, then Q, sir 1 Faraday, Q also is given 1 Faraday, then 1 Faraday, then 1 Faraday, both are cancelled with each other, then M equals to equivalent, that is E nothing but equivalent substance, equivalent substance. So gram equivalent weight of this substance is the answer for this. Understand? Yes. So M equals to Z by Q, then E divided by 1 Faraday into 1 Faraday, then you can get the answer. Okay. Yes, note it. One more question, note it, my dear students. One more question based on the Faraday's first law only. Okay, clear? Right. So note all of you. So note the question. Note the question. 1 liter solution of MgCl2, magnesium chloride. 1 liter solution of MgCl2, magnesium chloride. Magnesium chloride is electrolyzed. Then completely bypassing a current of 1 ampere for 16 minutes 5 seconds. 16 minutes 5 seconds. The original concentration of MgCl2 solution was, the original concentration of MgCl2 was, then magnesium atomic weight is given, that is 24. They are mentioned like this. Then options are given, my dear students. Then 5 into 10 to the power of minus 3 molarity. Then number 2, 5 into 10 to the power of minus 2 molarity. Then number 3, 0.5 into 10 to the power of minus 3 molarity. The number 4, 1 into 10 to the power of minus 2 molarity. Clear? So these are the concentrations they are given. So observe it carefully. Very important question it is. In the previous question also. So 1 liter solution of MgCl2 is electrolyzed completely by passing a current of 1 ampere of 16 minutes So 16 minutes 5 seconds they are given. 16 minutes 5 seconds. Okay, clear? Right. So now we have to take first MgCl2. MgCl2 can be dissociated into Mg plus 2 electrons, 2 Cl minus, right? First, at anode what happens? Anode దగ్గర ఏం జరుగుతాం? So anode దగ్గర 2 Cl minus can be converted into then Cl2 plus 2 electrons. 2 electrons. Okay. Then at cathode ఏం జరుగుతా ఉంది? Sir, cathode దగ్గర ఏం జరుగుతా ఉంది అంటే sir Mg plus 2 by taking of 2 electrons can be converted into Mg గా కన్వర్ట్ అవుతాం. Okay. So now we have to find out this amount and this amount, both amounts we have to find out. So నేను ఫస్ట్ అమౌంట్ ఆఫ్ క్లోరిన్ ఎంత డిపాజిట్ అయిందో ఫైండ్ అవుట్ చేస్తాను. సో మాస్ ఆఫ్ క్లోరిన్ ఈక్వల్స్ టు దెన్ మాలిక్యులర్ వెయిట్ ఆఫ్ క్లోరిన్ డివైడెడ్ బై n ఫ్యాక్టర్ ఇంటూ 1/96,500 coulombs into then I into T, I 1 ampere. So time 16 minutes and 5 seconds, nothing but so 1660. Then you can get it is 960, then 5 seconds plus 5 seconds. So 965 seconds. So 965 seconds you can take. Clear, my dear students? Then molecular weight of chlorine gas Cl2 35.5 plus 35.5, that is 71 divided by n factor. N factor is what? 2 electrons. Then into so 965 divided by 96500, right? Then 100 times it will go. Then once, then 35.5. So you can get it is 35.5 into 10 to the power of minus 2 grams. You can get the chlorine gas. Then the same mass of magnesium also you have to find out. Mass of magnesium. So mass of magnesium ela తీసుకోవాలి? Atomic weight of magnesium, that is 24 divided by then n factor 2, then that is again same 16, same 965 seconds divided by 96500, then again 100 times, then 2 ones are 12, then 12 into 10 to the power of minus 2 grams you can get. Now total mass in case if you take, so that is what? Mass of Cl2 plus then mass of magnesium Mg, it is equals to, you can get it is then 12 plus 35.5, then 47.5 into 10 to the power of minus 2 grams you can get. So this is magnesium chloride mass. Then molarity you have to find out, right? So molarity equals to given weight divided by molecular weight into then 1 liter. So 1 liter you have to take 1 by 1 you can get, right? So if you get the moles, then for 1 liter you can get. So weight how much is given? Then 47.5 into 10 to the power of minus 2 divided by molecular mass of MgCl2. Molecular mass of MgCl2 how much, man? Then 71 for chlorine. So magnesium 24. Then you can get it is 5. Then 7 plus 2, 95. So 95 divided by 95. So then you can get there is a 47.1 times. So then 2 times. Then 1 by 2 you can get it is 0.5. 0.5 into 10 to the power of minus 2. Then 5 into 10 to the power of minus 3. So this is the actual molarity or original molarity, that is 5 into 10 to the power of minus 3. Where it will be there? So first option is correct answer, 10 to the power of minus 3 molarity. So look at, my dear students, very important question. So you have to note it. Okay. Yes, clear? So we will see next law, that is Faraday's second law. So Faraday's first law we are discussing, right? Now Faraday's second law, and based on that problems also we have to discuss. So now Faraday's second law. Sir, Faraday's first law we are discussing the amount of substance deposited or liberated. The amount of substance deposited or liberated is directly proportional to quantity of current we are discussing. Now here, my dear students, sir, which one it is? Faraday's second law. Faraday's second law have to discuss. So what is the Faraday's second law? Sir, here two electrolytic cells we are taking. Two electrolytic cells. So two electrolytic cells, just assume it, this is the zinc sulfate, then this is the copper sulfate. So now two electrodes, either inert electrodes or the same electrodes, both are connected in a series. Both are connected in a series. So now same quantity of current when it is passed through the different electrolytic solutions. Same quantity of current is passed. Same quantity of current, nothing but, sir, actually quantity of current is I into what? T. Sir, I it is equals to same. Then time also same. Sir, rendu kuda same for both. So same for both. So quantity of current also both. Same. Quantity of current also same for both. Clear, my dear students? Now, sir, here same quantity, that is Q equals to I into T. Then even here also Q equals to I into T. Same quantity of current is. Now mass of this substance is equals to, so that is Z into Q, right? So nothing but Z into I into T. So once mass of zinc is deposited, zinc. Then here the mass of copper, it is equals to, so that is also Z into I into T, right? Okay, right. Then here the mass of zinc, we can also take it as, so equivalent weight of the zinc divided by Faraday into, sir, I into T. Then even here, sir, mass of the copper equals to, then equivalent weight of the copper divided by, then Faraday, equivalent weight of the copper divided by Faraday into I into T. In case the ratio of both mass and zinc, if you take the ratio of mass of the zinc and mass of the copper, if you take, then mass of the zinc, then here what is there? Equivalent weight of the zinc divided by Faraday into I into T divided by, then here equivalent weight of the copper divided by Faraday into I into T. Sir, here IT, then IT cancel, then Faraday cancel, then mass of the zinc, then divided by mass of the copper, it is equals to equivalent weight of the zinc divided by equivalent weight of the copper, right? So this is the Faraday's second law. That is Faraday's second law. So what is the statement of Faraday's second law? What is the statement of Faraday's second law? Here the same amount of current is passed through. Same amount of current is passed through different electrolytic solutions. So here electrolytes are there. So zinc sulfate is there. Then here copper sulfate is there. Sir, both electrolytic solutions, same quantity of current is passed. Then amount of substance deposited or liberated is directly proportional to proportional to, directly proportional to their equivalent masses, their equivalent masses, their equivalent masses, their equivalent masses. That's what. Sir, mass of the substance is equals to equivalent mass of the zinc. Then mass of the copper is equals to equivalent mass of the copper. This is the Faraday's. This is the Faraday's second law. So what I told, the Faraday's second law, same quantity of current is passed through different electrolytic solutions. Mass of the amount of zinc, how much is deposited there, that is equals to equivalent mass of the zinc. Even here also, mass of the copper deposited at this electrode, it is equals to equivalent weight of the copper. Okay, clear? Clear, my dear students? This formula you have to remember, then you can do the problems based on it. So we will see one of the question based on it. Faraday's second law మీద questions, the statement note చేయండి, formulas కూడా note చేయండి. So now we'll see one of the question. We will see one of the question based on Faraday's second law. Based on Faraday's second law. So that's a question, note it all of you. Same electric current is passed through a solution of, same electric current is passed through a solution of, aqueous HCl and ZnSO4, zinc sulfate. If 12 grams of hydrogen gas is liberated, if 12 grams of H2 gas liberated, find the mass of copper deposited. Find the mass of copper deposited. That is the question. Clear, my dear students? Clear, my dear students? Yes, look at. Sir, here two electrolytic cells are there. Two electrolytic cells are there. One is aqueous HCl, one more aqueous zinc sulfate, ZnSO4 is there. So now here two electrodes, even here two electrodes, here two electrodes, then two electrodes. They all are connected to the battery. Then in a series like this, same quantity of current is passed. Here the mass of hydrogen is deposited. Then the mass of zinc is deposited there. I told that mass of the hydrogen divided by the sorry, mass of the zinc, that is equals to equivalent mass of the hydrogen divided by equivalent mass of the zinc. Clear? Sir, equivalent mass of the hydrogen, how to find out? Equivalent mass of the hydrogen, that is equals to molecular weight divided by n factor, right? So molecular weight of hydrogen is 2, then n factor for the formation of hydrogen. So look at, for example, so 2H plus by taking of 2 electrons, then H2 gas will be liberated, then n factor is 2. So 2, then you can get equivalent weight of H2 is 2. So same like that, equivalent weight of copper in case if you find out, zinc if you find out. So equivalent weight of zinc, it is equals to, then molecular weight of zinc divided by then n factor, that is 2. Sir, molecular weight of zinc, not zinc, right? So they are given copper deposited, sorry, very sorry, right? So this is not zinc, copper sulfate, sorry. Mass of copper, then the equivalent mass of copper. So that is 63.5 divided by then 2. 63.5 divided by 2. Then equivalent mass, how can you can get for the copper? 31.75 can get, right? The copper it is 37.15 can get. So mass of hydrogen already is given, that is 12 grams divided by mass of copper you have to find out. Then equivalent mass of hydrogen is, I told that you can get it is 1. 1 divided by equivalent weight of copper is 37.15. Clear, my dear students? Then the mass of copper you have to find out. The mass of the copper, cross multiplication if you do, the mass of copper is equals to 12 into 37.15. Then you can get the answer, that is 381 grams. 381 grams. So you have to do like this. So this is the Faraday's second law question. So Faraday's second law. Faraday's second law. So based on the Faraday's second law. So my dear students, in this video, we are seeing what is Faraday's first law and Faraday's second law. How to calculate the mass deposited at the different electrodes in the second law. And at one electrode in the first law that we are discussing. Then the previous session and the previous video we are discussed about the electrolysis. So next video we have to discuss about that is conductance, then molar conductance and equivalent conductance, then all the terms what we are discussed in the electrolytic conductance that we have to discuss. Thank you very much. Then please subscribe and support to me.